Hey everyone, I just want to continue with the chapter 2 notes. This is page 3, talking about frequency histograms. So we're going to convert that distribution table that we just created into a graph. Some features about a histogram are here, so you can kind of check those out. Horizontal scale is the measure of the data entries. Like in this glass example, the exam scores would be along your horizontal scale. And then the vertical scale is going to be frequencies. So the height of each bar basically is going to be how many students were in that class. And then one other thing, a relative frequency, just your y-axis is going to be labeled with the relative frequencies instead of standard counts frequencies. Okay, new thing here is going to be called class boundaries. Class boundaries are just numbers that separate classes without forming gaps. Okay, another way to get class boundaries, averaging together two consecutive midpoints. I'll get to class boundaries when we look at an example here. So here's an example of a frequency histogram. We've got 3 bars, which means we have 3 classes. So notice the height of each bar is the frequency of the class. And then here, the midpoints are used to create this frequency distribution as opposed to class boundaries, right? That's pretty typical. Makes it a little cleaner if you just use the midpoints on your frequency histogram. Okay, and so let's answer the questions based off of this graph. We have list the midpoints. Okay, there's only 3 bars, so there's 3 midpoints, and those are just the ones right in the middle of the bar, right? So each bar has a midpoint. Okay, that's basically the average salary of each of those classes. How about the class width? Okay, class width is going to be the difference between 2 midpoints. That's one way to do it, right? So class width, I could just do 49.5 minus 43.5, and that's going to be 6. All right. Class boundaries. Now you can find class boundaries by averaging 2 midpoints together. It doesn't matter which 2 you choose. So if I take 37.5 plus 43.5 and divide by 2, that would be what's called a class boundary. That would be a 40.5. Okay. Now, where that is on the graph, 40.5, that's where the bars touch. So class boundaries are just that, where the bars touch on the x-axis. So if I squeeze that in right there, it's that spot. That's the class boundary, 40.5. Okay, so class boundaries appear on a graph. They don't appear in the table. If we look back on that previous example, this one we never talked about class boundaries because we didn't create a graph for it, but we will. But a class boundary, another way, if you have classes here, right, a boundary is just a value between 2 classes. It's halfway between 2. So this class ends at 59 and starts at 60. There's a gap there, right? All the numbers between 59 and 60. A boundary is halfway between those 2. So this one would have a class boundary of 59.5 between those 2 classes, okay? All right. So this one, we didn't quite finish it. List the class boundaries. I only found one of them. But anytime you find one, use your class width to generate all of them, right? So the next one over, that one, would just be add 6. 46.5 would be the next one. And you also want to include the very last and the very first class boundary, okay? So to get this one here, I would just subtract 6 from that one, right? So if I take 40.5 minus 6, that would be a 34.5. That's that value. It's getting really messy with my arrow. And then this one, it's 6 above this one. Okay. And so that would be 46.5 plus 6. 52.5. I always rewrite these notes and put them in the one-stop shop. So I know it gets a little messy when I'm doing this in the videos, but if you look at those notes that I've rewritten, it'll look so much nicer. Okay, find the relative frequency of the first class. Oops, no, D, didn't do D yet. What is the total number of employees represented in this histogram? Okay, that's the sum of the frequencies. That's the sum of all of the heights of all of the bars, right? So 3, so we got 3, 6, 1. Add those together and you've got it. So 3 plus 6 plus 1, looks like we've got 10 employees. Find the relative frequency of the first class. The first class has a frequency of 3. The total frequency is 10. 3 divided by 10 is 0.3. That's the relative frequency. All right, now we got our head around a frequency histogram. Let's draw a frequency histogram for the data on page 2. That's the exam data. So the first step is to label the axes. One thing to do is you can make a little this thing. You have it here too. That's just showing that you're not really starting at 0. You're skipping a bunch of values, and we're going to start at that first midpoint, right? So what I like to do is just label midpoints. So if I go back to my frequency table, I'm going to use those as my labels for the x-axis. Again, your other option is class boundaries. You could do it that way too. But midpoints are my favorite way because it's just less clutter. Okay, so my first one is 54.5. Right, and then I'm just going to space them out evenly. I know they all differ by 10 because that was the class width. Okay, those are my 5 midpoints. And then that's going to be the center of each bar, right? And then the height of the bar is the frequency. So notice the highest one I had was 15. So over here, I'll probably just go 5, 10, 15, right? And then get it pretty close. So for the first one, the frequency was 6. So I'd go to there, right? The next one, the frequency was 4. So that's going to go down. The next one, we were up to 15. And then, what was it, 9? 6, 4, yeah, 15, 9, and then 7. Okay. 9, and then about 7. Okay. And there's your frequency histogram. Relative frequency histogram, you would just change these values to relative frequencies, okay? Percentages or proportions. Otherwise, everything would be the same. Even the structure and the shape would look the same. Okay, so it gives you, a pretty good idea of the distribution of these scores, right? Got a lot in the middle, but got a little bit more 80s and 90s than 50s and 60s, which is a good thing. This one would be called skewed left. We'll get to that later. Okay, frequency polygon is a line graph, and you use the midpoints from the frequency distribution, but you just do lines only. So again, I could do my little squiggly thing, 54, 64, 74, 84, 94, 0.5s. Okay, and then 5, 10, 15. Instead of doing bars at each frequency, you're just going to do a dot, right? So it's 6, 4, 15, 9, 7. Where that came from. And then you're going to draw a line, just straight lines connecting those dots. All right. And then they do end because it bottoms out right? That way and that way. Okay. That's it. All right, so it's just a different type of graphs, gives you the same information. I like histograms better, but you might see some polygons here and there. All right. Other than that, that's your 2.1. So I'll stop there for this video, and then in the next one, we'll start up 2.2. Send questions my way if you have any as you're going through that homework. Okay, hope all is well. Bye.